Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 1162 that says as far from land as possible. So here we are given one n cross n grid or matrix that contains 0 and 1, where 0 represents water and 1 represents land. So we need to find a water cell that's its distance to the nearest land cell is maximized. Means we need to find a water cell whose the nearest land cell is as far as possible. As the question says, as far from land as possible. So we need to find such type of water cell. And further, if no such land or water exists in the grid, then return -1. Yeah. And the distance that we are talking here about is Manhattan distance. That is the distance of the adjacent element. This is x0 minus x1 plus y0 minus y1. Okay. So yeah, let's take a look at the example to get better understanding. So here this is with the grid we are given here. The zeros are all water cells and 1 are land cells. So let's talk about this 0. The nearest land cell is this or this. So it is at a distance 1, right, for this 0. For this middle 0, the nearest land cell is either this, that is at a distance 2, or this at a distance 2, or this at a distance 2. See, the one distance is here from this middle to this right, and one from this right to down. So this is how two length distance is the distance of the nearest land cell from this middle 0. Got it? So yeah, no other zeros has a better answer or farther land as compared to this 0, and that's why we written 2 here. This is the best possible answer we can get. Now let's take a look at this example. So here, if you talk about this 0, right, this is at a distance 1 from the land cell, correct? This 0, it is at a distance 2. See, one distance is here and another is here. So this is how distance 2 for this 0, and this 0, right, it is at a distance what, 4. One distance, second distance, third distance, and fourth distance. So like within 4 adjacent jump you can reach the land cell. This is the minimum number of jumps or distance you can say. This water cell is further from this land cell, right? So we written 4 as our answer. So I hope you guys understood the question, right? It is a simple question that we just need to find the Manhattan distance between the water cell and the land cell, right? And yeah, if you take a look at the constant here, the maximum n is 100, so the total size would be 100 into 100, that is 10,000. Yeah, the 10,000 total cells will be possible in a grid, and each grid contains only 0 and 1, that is either water or land cell. So yeah, from this what you can understand, that let me write this down. See, few things are clear from this question, that this is a graph, right? Graph plus we only need to do traversal, correct? And from each water cell we need to find minimum distance or shortest, you can say shortest distance land cell, right? Land cell. This is what we need to do. So whenever we need to find some of this, something like this, like minimum distance or shortest distance land cell, then what we can do? We can do traversal like BFS, correct? Up till here, everything is so far so good. Now since we are doing BFS, so we will keep one visited area also, visited area of size n cross n, to make sure that that cell is visited or not. Now the question arises here is either to do BFS starting with zeros or starting with ones, right? Means initially you need to fill something in this BFS queue, right? Then what you will fill? You will fill all the zeros or all the ones, right? That's the question mark. How you will start doing BFS, correct? See, if you do, let's say for this example, you might be thinking that we will store the zeros and we will find for all the zeros we will store in the queue, and we will find the minimum distance 1 from that 0. Okay, that's a first thought if you think like that. So we will check that what will happen if we store all the zeros in the queue and start finding the minimum distance land cell, right? What would that happen? So let's say we have visited array of size n cross n, right? Now let's say this okay, so let's say this 0, we are traversing first this 0, so this 0 has traversed this cell, right? Now this is visited, so for the visited, let me just write it as V. So now this cell is visited. So from here, let's say this this 0 goes to here. Okay, so for this 0 the minimum distance would be 2. Minimum distance it got is 2, right? No better answer is possible for here for this 0, right? Now let's talk about this 0. Okay, so it will traverse here. Okay, um, so this cell is not visited, right? Assume that. Okay, this cell is not visited by any zero. But so now currently the distance, this zero has traversed the one distance, right? From here it traversed to here, right? Now this zero, we'll see that this cell is visited by another zero, right? So this won't be able to traverse it till here. Okay, means this cell won't, it can, this zero can't traverse this cell, right? But that is wrong. As you can see that if you want this zero to traverse till this length cell, then it has to go from here to here. Okay, yeah. And if you that means that there is that in this visited array, for each I and j, we also need to keep track of this cell is visited by which zero, by which zero, like either this zero or this zero, correct? Else you won't get a good answer. It's simple as it is, right? So along with this visited array, we need something that we have to keep track that by which zero this cell is visited. Okay, that's the issue if you try to fill this queue of BFS queue with all the zeros. Now let's take a look if you try to do the same by filling the queue with ones. Okay, let us do that. Here in the same example, we will do a dry run of a BFS and we will check that 1 1. So currently our queue has ones, right? This one and this one, right? Okay, now let's say this one visited this zero. Yeah, it is now visited, and also this zero. It means we are doing a BFS, so it will track all the adjacent cells, right? These two cells are visited. For this one, it has visited this. It didn't visited it this. Okay, any issues? No issues. Why this cell doesn't visited this? Do we have any issues? Will that be any changes in the answer? No, because for whichever length cell will visit the water cell, we don't have any issue, correct? So till here for this cell we will get answer 1, for this also 1, this also 1. Now after here this will go to here. Okay, and after here this will go to here, and this will go to here. We will get 2 2 2 as our answer, and let's say this will go to here, so we will get 3 as our answer. Got it? So if the cell is already visited by some other land cell, then we don't have any issue, because because we need to find the shortest distance land cell from each water cell. So either this cell will, so let's take a look at this example. Either this cell will visit first or this. We don't have any issue because both are at same distance. But while doing traversal from water cell to land cell, we have issues, because let's say this cell is itself visited, then this zero won't be able to go till here, right? We won't be able to find distance if you try to do from if you try to go from 0 to 1, right? We have to store which zero has visited that cell by taking this. But here it's simple. We will keep visited array of size n cross n, simple, and we don't care which one which length cell has visited that zero cell. I hope these things are clear, right? This is simple as it is, that you just need to make a thought that either you should go from or water cell to land cell, or from land cell to water cell, right? Because the simple thing is all water cell are not equal because of the distance, but all land cell can be treated equal, right? Whichever land cell will visit that water cell first, it's one and the same, right? So yeah, I hope you guys understood the BFS approach how to solve this question. Now what I tell that this BFS approach is good, okay, but we can solve this question in some better way also by using DP approach. So yeah, now we will talk about dynamic programming approach as well, that how dynamic programming approach will work. So I will show you that. Let me draw the same example again. So here we have 1 1 and we have 0 0 0 0 0 0 0. So yeah, if you think about dynamic programming, so let's forget we are doing something like dynamic programming. First let's just try to understand that what we are doing here. See, in order to find distance, we are checking the distance from the adjacent element. Let's say see the we will also note one distance here. Let's say the distance of here, the distance array is 0 because it is itself a land cell, so distance from the nearest land cell is 0. Okay, now for this water cell, what would be the distance of the nearest land cell? It would be adjacent cell plus 1, right? Minimum of any of the adjacent cell. So let's say here the adjacent cell distance is 0, and here so it would be plus 1 because it is a water cell. so it would be 1 here. Here also 0 because it is land cell itself. So now let us take a look at here. We will try to fill the distance cell, right? This is the distance we are filling. So for this cell, its adjacent, what would be the distance? Its distance would be minimum of adjacent plus 1. So minimum of adjacent here is 0. Here, so initially all have max value, right? All have max. This is also max initially, right? So minimum distance of its adjacent cell is 0 and it would be 0 plus 1, so 1. Now let's talk about this. Now the minimum distance this 0 can have from the adjacent is 1, right? This one or this one. So total distance here for this cell is 2. For this, its minimum distance is this 0, right? 0 plus 1, 1. For this cell, the minimum distance is this, right? And we do 1 plus 1, that is 2. For this, its minimum distance here, see, it's this side is 2, the upper side is also 2, and here it is max. We haven't initialized this, so it is 2 plus 1, it's 3, and here minimum distance is 1, right? Not 3, 1. From its adjacent minimum distance cell is 1, so we do 1 plus 1, that is 2. So what we are doing here is we are just checking the adjacent cell, right? And for each lens cell we are marking the distance as 0, and for each water cell we are checking the minimum distance from its 4 side adjacent cell. Let's say for this the 4 side are this, and this. We will take the minimum distance of this cell and we will just simply do plus 1. Is this correct? Yeah, it is definitely correct. And what we are doing here, we are simply doing DP, right? We are storing the minimum distance of the adjacent cell, and based on the adjacent cell we are updating the distance. Yeah, what we are simply doing, update distance from adjacent, simple as it is. Yeah, because this same thing also we are doing in BFS, right? Based on the adjacent distance only we are doing plus 1, correct? And we can do the same thing here. Okay, so yeah, we will code for this approach. So currently you will think that here also we will need a distance array. That would be a space of n square, big of n square, space complexity. Okay, but yeah, we will reduce this big of n square to big of 1, and we will do that while coding. Okay, so whatever approach you have to do, I mean you have to select whatever approach you want to do. This BFS approach would be also big of n square in time complexity, and space complexity would be also big of n square. But this DP approach, though the time complexity would be big of n square, we will reduce the space complexity to big of 1, right? And we will do that in the code. So I hope you guys understood the question, how we are building the approach, like how we are building the BFS approach and what to do, either to start with zeros or ones. And second thing is how we are doing DP, right? How we are updating the distance. So I hope you guys understood this. Now let's move on to the coding part, where we will see the code of both the approach, right? So let me first show you the approach for the BFS traversal, using the BFS traversal. So as you guys can see here, initially I took this direction pair because there was only 4 direction. This is fixed, right? Left, right, top and down. Then we created a visited array of size n cross n, and we fill this visited array with zeros and ones, because let's say this is the pair. In the pair we are only storing all the ones, right? If grade of ij equal to 1, and we are marking it visited because the lens cell is visited and all the water cell are not visited, so we will mark it as 0. So same value we are filling from the grid, correct? Now what we are doing, we are traversing all the lens cell that are present in this queue. Okay, we are traversing all the lens cell, and from the lens cell we are traversing in all 4 direction, right, using this direction vector. And if any of the cell is not visited, that means that would be a water cell only, because the lens cell are already visited, correct? So it means in the first dry run all the non-visited cell would be water cell, and afterwards we are keep visiting the water cell as well, as you can see here. And we push we will just push that in the queue, and at the end after this means all the current one cell have visited the nearby water cell, which simply make the distance plus by, because let's say this lens cell has visited this water cell, and this has visited this. So all this distance is 1, right? As you can see here, 1, 1 and 1, because all the water cell will visit adjacent cell, and the distance from that cell would be distance plus, that is 1, initially 1. Then after from here, this we have visited this has visited this has visited this, so the distance is 2. All this water cell has same distance, that is 2. So that's why we are updating the distance at the end, right, after visiting all the possible water cell. Now we will do the similar thing here by using a dynamic programming. So now let us start coding that. So initially let me take n as the size of the grid. So here the number of rows is equal to number of columns because the grid is n cross n. That is a square type of matrix. We will also take one max d there where we will store the maximum distance. So the maximum distance would possible here is number of rows plus number of columns plus 1, correct? Now further what we will do, we will create one vector of int, a 2D vector. Let me name it as distance of size n, comma vector int of size n, and initialize with maximum distance. So currently what we are doing an approach with a space complexity of big O of n square, and further I will show you that how you can improve or how we can reduce this to big O of 1. Okay, we will do in a while, correct? Now we will traverse from I equals to 0. We will traverse all the cells. J is less than n, j plus plus. Okay, now one thing I forgot here is in this DP approach, right? We will loop 2 times. We will loop 2 times. Why? So let me tell you first that we will loop from top left. This is first time, and second time we will loop from bottom right. Why? So if you are so let's say this is the, again let me draw it, 1 1 0 0 0 0 0 0 0. So initially see we can't loop, so initially we will check only top left right, top left cell. So let's say for this cell we will check this top cell and the left cell. Why? You might be thinking why? Because at a time you can only traverse from one side, right? You have traversed these, then these, yeah, then afterwards these. So only the top or the left cells are traversed at first, right? So you will find the minimum distance from the top left, and secondly in the second traversal you will find the minimum distance from the bottom right, correct? This reason is as simple that at one time you can only traverse from one end, right? From the either top left or bottom right. So the visited area would be top left. So for each cell in a first traversal we will check from the top and the left, because the below both are max distance, right? Initially everything is max, these two would be max, so checking that would be of no use because they are not visited from the bottom. So since we are traversing from the top left, we will only check for 2 direction, top and left. And here when we are traversing for the bottom and right, we will check for 2 direction, bottom and right. This is as simple as this, because the cells of the top and left are visited here and here, bottom and right. We can't visit all 4 cells at a time. If we have to do that, then we have BFS. If you want to visit all 4 cell at a time, then what you can do? You can do BFS, but you can't do by using 2 for loops right here. So that's why we are traversing top and left here, and afterwards we traverse bottom right. Okay, now if let's say if the grid of ij equals to 1, that means we have a length cell, then in that case we will simply we will simply make distance of ij equal to 0. And in the else condition, what we will do? We will simply do distance of ij equals to minimum of 2, that is top and the left. So yeah, so for the top we will check this condition, if I is greater than 0, just to check that we are not out of bounds. Then distance of I minus 1, j plus 1, that is the top cell distance, plus 1. Or if it is not less than 0, then we will only provide maximum distance, right? So this is one thing, comma, and we will also check for j greater than 0, question mark, then distance of I j minus 1 plus 1 as maximum distance, right? Okay, let me also put this in the bracket. So yeah, we are finding minimum of this top and left, and we are updating the distance area, correct? Now here we have started the loop from top left. The same we would do from bottom right. Now before that, let me also initialize our answer as int mean. Okay, and here we will start from bottom right, that is n minus 1, n greater, so I is equal to n minus 1, I greater than equal to 0, and doing I plus I minus minus, and same thing here, j equals to n minus 1, j greater than equal to 0, j minus minus. Here also this condition would remain the same. If we have land, then we will keep it as it is, but I don't think that we will require this condition because the lands are already visited, correct? Here in the all the lands are already visited, right? There won't be any change. And here we have to check for one thing, that I should be less than n minus 1. Okay, then only we can do I plus 1 comma j and j, and here also j should be less than n minus 1. In that case only we can do j plus 1, that is the rightmost cell, right? And yeah, everything looks perfect apart from this. And yeah, one another thing is we have to check for distance. Answer would be, sorry, the maximum of answer comma distance of ij, and in the end we will simply return our answer. So yeah, I hope you guys understood this code. Now let me try to run this. Okay, here it would be colon, so same thing would be here, we are missing colon. Okay, one thing we are also forgetting, that if it is already minimum with the current distance, that is distance of ij, then we won't update it, right? If initially we got some minimum distance, then we won't update this, correct? So yeah, we need to check that also. Okay, it's dist. Okay, it's showing some wrong answer. Okay, so here in during answer, what we need to check, if answer equals to 0 or answer equals to maximum distance, in that case we will simply return -1 as answer. Why? Because if the answer equal to 0, that means there is no water cell, and answer equal to maximum distance, that means there is no land cell, right? So yeah, if there is no land cell or no water cell, then we would return -1 as the answer. Now let me try to submit this again. So guys, as you can see that our code got accepted. Now as I told you that this was this here we are using a distance array, and that will take a time complexity, right? So here what we will do, we won't take the distance array, and we will simply update this grid array, correct? And the only thing you need to change here is wherever there is a distance, we will take simply the grid array. That means we are simply updating the distance in the grid array itself instead of using any distance array. So yeah, everything is updated. So now let me try to again run this. Okay, so here also we need to do one thing, the grid of ij equals to maximum distance. Why? Because if there is a water cell, then we will initialize with a maximum distance, as we did here in this visited array. So first we initialize that with a maximum distance, then we would change it to better answer. So yeah, let us try to run this again. So guys, as you can see here that by using a DP approach and doing the solution in big of one time space complexity, we also solve this question. So yeah, I hope you guys understood the approach, the intuition, and also the coding part for both the solution for this DP approach as well as this BFS approach. And if you have still any doubts, then do let me know in the comment section. So yeah, that's all from my side today. Make sure to like this video and subscribe to our channel. Thank you.